Now let's try to solve a system of linear equations using the matrices. So solve a system of linear equations using matrices. Before we solve, we introduce the next concept. Let's see the example and see why we are interested in such concept. So, for example, if we have x plus 2y plus z is 4, I just try to get such stuff. Y plus 2z is equal to 1, whatever number, and z is equal to 3. Okay, assume we can get such equations, system equations. Then what we can see, we start from here, we know z is equal to 3, and then we go back, we substitute back. So z is 3, 2 times 3 is 6, y plus 6 is 1, so you can solve y as 1 minus 2z is negative 5. Okay, so you get a y is negative 5, z is 3. You continue move to the first equation, it's a 4 minus 2y minus z is 4 minus 2 times y is negative 5 minus z is 3. So 2 times negative 5 is negative 10, minus is plus, it's a 14 minus 3 is 11. So then you see what we get. We solve it. So the solution will be 11, negative 5, and negative 3. All right? So assume we have such system of linear equations, we actually can solve it. So what is the property of such system of linear equations in the viewpoint of a matrix? Let's check. The corresponding augmented matrix will be 1, 2, 1, 4, and 0, 1, 2, 1, and 0, 0, 1, and 3. It is augmented, so we draw this vertical segment. So let's check let's summarize the property of such matrix. The first row starts from 1. The first row, first entry is 1. Below it is always 0. And the other row, the first entry, first non-zero entry is 1. For the second and third row, or if you have more rows, the first non-zero entry is always 1. And below that 1 is always 0. Okay? Here is 2. It doesn't matter. It's not below it. Below the 1 is always 0. If such augmented matrix exists, then the corresponding system of linear equations can be solved by this back substitution. And this type of matrix is called an echelon form, a row echelon form. Row echelon form. Okay, so let's give the detailed definition. Okay, a matrix is in row echelon form when the following conditions are met. Okay, so you have several conditions. First condition, the entry in row 1, column 1. In row 1, column 1, like top left entry is 1. the entry in row 1, column 1 is a 1. And only zeros appear below it. Okay, so this is a 1. Below it, they must be always 0. And second, the first non-zero entry in each row after the first row is 1. So you see the second row, the first non-zero entry, this is a 0. So this is a first non-zero entry. It must be 1. It cannot be 2, 3, 4, whatever others. Okay? And only zeros appear below it. Whenever you see number 1 as the first entry from the row, then below it, all the entries must be 0. Okay? And the 1, okay, let me finish it. The 1 appears to the right of the first non-zero entry in any row above. So this means, you see here, well, this number 1 cannot appear in the first column, because first column, we know the first row, first entry, first row, first column, this point is 1, and below it is always 0. So the non-zero entry must be on the right side, on the right of the first non-zero entry in the above row. So it's always moved to the right. Every step you move it to the right. It may be just 1 step or maybe 2 steps. Okay, on the right, we don't say it's on the adjacent right position. It can be here or can be here. Okay, and that's why it's called echelon. It always go right, step by step. Okay, and 3, any row that contains all zeros to the left vertical, all 0 to the left of the vertical bar, vertical segment. This is vertical bar. All zeros to the left vertical bar appear at the bottom. Okay, so it means the following. You see here, it could be like this: 1, 1, 2, 0, 0, 1. Let's put 1, 2, 3, and 0, 0, 0. Okay, so this is also an echelon form, which means you see the 1, 1 position is a 1, and this row, the number 1 non-zero, first non-zero entry is on the left, on the right, my bad, on the right of the first non-zero entry in any above row. It's on the right side of this one, and any row that contain all zeros to the left of the vertical bar. This is left vertical bar. This row contains all 0. It will appear at the bottom. It will appear at the bottom. And if those 3 conditions a mat, we call them a row echelon form, the matrix in row echelon form. And we give such matrix a name because once you have a row echelon form, you can use this strategy, back substitution method, to solve the corresponding system of linear equations. Okay, so that is the reason. Okay, now let's see. If we have a general matrix not in the row echelon form, how can we write or how can we use row operation to get the equivalent row echelon form? Okay, so let's see. Example. Solve 2x plus 2y equal to 6, x plus y plus z equal to 1, 3x plus 4y minus z is equal to 13. We're trying to using matrices. We're using matrices to solve this system of equations, linear equations. Okay, so first we write the corresponding augmented matrix. The corresponding augmented matrix: 2, 2, 0, vertical bar, 6, 1, 1, 1, 3, 4, negative 1, and 13. Here's 1. Okay, so check here. The first condition, we want the top left entry to be number 1. Of course, we can multiply row operation. We can only perform row operation. We can only perform row operation. Okay, so you see here, first we can actually multiply the first row by 1/2, change it to be number 1. It's okay, it's not the problem. Or we can directly exchange the row 2 and the row 1. We can exchange row 2 and the row 1. Then directly we get number 1. Okay, so this operation, the new row 2 is original row 1. The new row 1 is original row 2. This is our row operation, exchange two rows. Remember, when you change row, you have to change the complete row, including the number on the right side of the vertical bar. So this 2, 2, 0, 6, 3, 4, negative 1, 13. It's the first step, exchange. Okay, now I want to make this number 0. I want to make this number 0. Okay, how can I get this number 0? I'm going to use the following one. Our new R2 is original R2 minus twice of R1. So you multiply the first row by 2, you will get the number 2. 2 minus number 2 is 0, right? So first you copy the first row. This one minus twice of 1. 2 minus 2, 0. 2 minus 2, 0. 0 minus 2, remember you multiply the first row by 2. 0 minus 2, negative 2. 6 minus 2, 6 minus 2 is 4. Okay. For the row 3, we also want to make this number 3 not 0. How do we do that? We get a new row 3 as the original row 3 minus 3 times R1. So 3 times 3 minus 3 times 1, 0, right? So we multiply this row by 3. You will get a 3, 3, 3. And you use a 3, 4, negative 1, 13 to subtract it, all 3. So 3 minus 3, 0. 4 minus 1, 4 minus 3, 1. Negative 1 minus 3, negative 4. 13 minus 3, 10. 13 minus 3, 10. So we have such thing. Okay, so we just multiply. Okay, see, check here. This in this case, the first row unchanged because it's already good. We just use the second row to subtract twice a first row, and use the third row to subtract the 3 times the first row. This is one of our row operations. And then you see this is number 1. Here, this is non-zero, first non-zero entry. This is the first non-zero entry. If we want to make it 1, we have to divide this whole row by -2. But I can exchange row 2 and row 3. So row 3 is row 2 and row 2 is row 3. Every time the capital R will mean the resulting row, and little r will mean the original row. Original for the current step, not the original, very beginning original. Okay, so I'm going to exchange the row 2 and row 1, row 2 and row 3. Right? So check here. Now the first non-zero entry in the second row is a 1. Below number 1, it's always 0. So we are okay about the second row. And third row, the first non-zero entry is -2. Well, it's not a 1. We divide the third row by -2. 0, 0, 1, -2. 4 is divided by -2 is equal to -2. Okay, so now we have the row echelon form. This is a row echelon form. For the row echelon form, let's write down the corresponding system of linear equations. So x, this is x plus y plus z is equal to 1. That's the first row. Here, y minus 4z is equal to 10. And here, z is equal to -2. Okay, you should be able to write the augmented matrix from a given system, or you can also write down the system from the given augmented matrix. And now you see z is a -2. You go back, back substitute, y is a 10 plus 4 times z. 10 plus 4 times z. 4 times z is -8. 10 plus -8 is 2. And then we continue move back. So x is a 1 minus y minus z. 1 minus y is 2. Minus z. Z is -2. Is a 1. Minus -2 is plus 2. Minus 2 plus 2 is nothing. So it's just 1. So the solution is ordered triple. 1, 2, and -2. And that's it. That's it. So what is the strategy? What is the method? We just try our best to make the given augmented matrix into the equivalent row echelon form. And every step can only be performed by row operation. You cannot do extra operation, just the row operation. Exchange two rows. See, multiply a row by certain non-zero number. Add or subtract certain multiple of a row to another row. Add or subtract. Right? Okay, now let's see another example. Let's see another example. You have to do it by yourself, at least 2 examples, so to memorize the process. The process is not difficult, but there are several steps. Okay, so we're going to solve x minus y plus z is equal to 8. 2x plus 3y minus z is equal to negative 2. And 3x minus 2y minus non-z is equal to 9. Right? Okay, now let's write down the augmented matrix. 1, negative 1, 1, 8. 2, 3, negative 1, negative 2. 3, negative 2, negative 9, 9. This is an augmented matrix. Okay, so first of all, this 1, 1 position is already number 1, perfect. So we will leave the first row alone. We will not do anything about the first row. And we are going to queue this number 2 and the number 3. So the new R2 is original R2 minus twice of R1. And the new R3 is going to be original R3 minus 3 times of R1. So 3 times of 1 is a 3. 3 minus 3, 0. So we just try to make this position and this position 0. So remember, we will leave first row alone. Don't change it. And here, so 2 minus 2, 0, because you're going to multiply the first row by number 2. 3 minus negative 2, 5. Negative 1 minus 2, negative 3. Negative 2 minus 16 is negative 18. Negative 2 minus 16. So if you are not familiar with this process, you just literally write down this one. And in the scratch paper. And you really do the subtraction one by one. You see? R2 minus twice of R1. This is twice of R1. This is R2. So 2 minus 2 is 0. 3 minus negative 2. This subtraction, always subtraction. 3 minus negative 2 is 5. Negative 1 minus negative 2 is negative 3. Negative 2 minus 16 is negative 18. Okay? Then R3 minus 3R1. So you see, 3R1. So 3, negative 3, 3, 24. This is a 3, negative 2, negative 9, 9. Let's do subtraction. 3 minus 3, 0. Negative 2 minus negative 3, 1. Negative 9 minus 3, what is it? It's negative 12. 9 minus 24, negative 15. Am I right? Yeah, I'm right. Okay, so next I'm going to exchange these two rows because I want this number 1 here. I want this number 1 here. So exchange it, we get 1, negative 1, 1, 8. 0, 1, negative 12, negative 15. Be careful, there's a vertical bar. 0, 5, negative 3, negative 18. You have to move all the rows down. Exchange all the rows, including the right numbers. Okay, then next, I'm going to make this number 0. So it's R3 minus 5 little r, oops, sorry, R3 is equal to the original R3 minus 5 times R2. Well, let's check. 5R2. 5R2 is a 0, 5, negative 60, negative 75. Here is 0, 5, negative 3, negative 18. Let's do subtraction, okay? So 5 minus 5 is 0. So this position is 0. So our goal is to make this 0. Negative 3 minus negative 60 is 57. Negative 18 minus 7 minus negative 75 is 57. It's 57. Let's just try it. Negative 18 minus negative 75 is 75 minus 18. Minus plus. So it's a 57. Okay? Okay, and then this number is the first non-zero number, but it's not a 1. So we will divide the row 3 by 57. We'll get a 1, negative 1, 1, 8, 0, 1, negative 12, negative 15, 0, 0, 1, and 1. Okay, so this is our augmented matrix in the echelon form, row echelon form. And once you reach the row echelon form, you're going to write the corresponding system of linear equations. Okay, so z is 1, y minus 12z is equal to negative 15, x minus y plus z is equal to 8. So z is 1, you move back, so y is negative 15 plus 12z, z is 1, so negative 3, and then you continue move back, x is 8 plus y minus z, 8 plus y minus z, 4. So the solution is 4, negative 3, and 1. See it? So it's a very, very efficient method. It's a very efficient method. All right. So remember, in the row echelon form, this is a 1, this is a 1, here should be 1. Below 1, it should be 0. We never require above 1, any condition about entries above 1. If it's above 1, it can be whatever number. Row echelon form does not require the entries above the leading number 1. Okay, so here it can be any number. So let's see this. For example, we're going to continue the discussion about this one. Okay, assume we get this so-called the row echelon form. I'm going to make this above entries all zeros. How do I do that? I have to do it from bottom to top. Okay, so here is a 1, here is negative 12. How do I make this term 0? I'm going to have row 2 as a new row 2 as original row 2 plus 12 times a row 3. This is a subtract minus 12, so we have to add 12, right? So it's a negative 1, 1, 1, negative 1, 1, 8, 0. Here, you see, times 12, 0 times 12, 0, 0 times 12, 0. So even you add, if even you just care the last entry, but first two entries never change because it's always 0. And this part becomes 0. And 12 times 1 is 12. Negative 15 plus 12 is negative 3. Okay? So you move back. And then you continue move back. I want to make this position 0. How do I do that? I just get new row 1 as a row 1 minus row 3. Row 1 minus row 3. So we'll get 1 minus 0, 1. Negative 1 minus 0, negative 1. 1 minus 1, 0. 8 minus 1, 7. 8 minus 1, 7. Wow, bad. 0, 1, 0, negative 3. 0, 0, 1, and 1. We're not done. Okay, so you see here, now above the last 1, all the entries are 0. Here, below the 1, all the entries are 0. Good. So this is not the condition in the row echelon form. It's just additional step we do. Let's see what we will get. Okay, so for this number 1, above this number, all the entries are 0. But for this number 1, here you still have a non-zero number. Okay, so how do I make this number 0? I will add the second row to the first row. So the row 1 is row 1 plus row 2. New row 1 is original row 1 plus row 2. 1 plus negative 1. You see, 1 plus 0, 1. Negative 1 plus 1, 0. 0 plus 0, 0. 7 plus negative 3, 4. and then you copy other rows. Okay, so now what we have this, whenever we have this echelon form, row echelon form, whenever you have a 1 below or above those number ones, all the entries are 0. Whenever you have those leading entry 1 below and above those number ones, all the entries are 0. If this happens, let's check what is the solution for -3 and 1. Check this column. This column give you the answer. This column will give you the solution. That's why we are interested in this process. And this is called the reduced row echelon form. It has even more condition. Entries above number 1 are always 0, are also 0. When this satisfied, this is called reduced. If you only require the entries below number 1s are 0, then that's called a row echelon form. Here is a reduced row echelon form. The advantage of the reduced echelon form is that you can read the answer from the matrix. Okay, and this method to find the reduced row echelon form and then to get the answer is called the Gauss-Jordan elimination. This method is called the Gauss-Jordan elimination. Okay. So this method will directly tell you, once you can reach this so-called reduced row echelon form, you can directly see what is the solution. In this example, we have the unique solution, and this is actually all. This method can actually tell us when the system has infinitely many solutions or it has no solutions. Actually, it's not just for this special case. For the unique solution case, it works for all the cases. Okay, let's see more examples. We will do more examples. Okay, so see, we're going to solve 6x minus y minus z is equal to 4, negative 12x plus 2y plus 2z is equal to negative 8, 5x plus y minus z is equal to 3. We're trying to use matrices to solve this system of linear equations. So we first write down the augmented matrix. Well, let's check. I want to make this position number 1. How do I get the number 1? I can multiply the first row by 1/6. So every number divided by 6, I can get number 1. But if I divide this position by 6, I will get a 1. But here, if I divide -1 by 6, I will get a -1/6. I want integer. I don't want fractions. So the strategy is the following. You see, here's 6, here's a 5. The new row 1 is original row 1 minus original row 3. I use 6 minus 5 to get 1. So 6 minus 5 is 1. -1 minus 1 is -2. -1 minus -1 is 0. 4 minus 3 is 1. Okay? So let's copy the other 2 rows. All right, then I'm going to make this position 0. How do I make this position 0? We will get a new row 2 as a, well, let's do it here, it's too long. new row 2 as the original row 2 plus 12 times row 1. I multiply the first row by 12 and add it to row 2. Let's check. Okay, so 1 times 12, negative 2 times 12, 0 times 12, 1 times 12. This is row 1, 12 row 1, and row 2, negative 12, 2, 2, negative 8. Let's do addition. So this is 0. 2 plus negative 24 is negative 22. 2 plus 0 is 2. Negative 8 plus 12 is 4. Okay. And for the row 3, I'm going to use new row 3 is equal to the row 3 minus 5 times R1. See, R1, 5 times R1 is 5, negative 10, 0, and 5. And the row 3 is 5, 1, negative 1, and 3. We do subtraction. 5 minus 5, 0. 1 minus negative 5, 11. Negative 1 minus 0, negative 1. 3 minus 5, negative 2. Okay. Okay, then what's next? Next, I'm going to, okay, here there's no way to make it simply 0. We just divide the row 2 by what? By negative 20, negative 22, row 2. So this one is divided by negative 22 is 1. 2 is divided by negative 22 is negative 1 over 11. 4 is divided by negative 22 is negative 2 over 11. Here is 0, 1, 1, 0, 11, negative 1, and then negative 2. Okay? And then I'm trying to make this 11 0. So we have row 3 is original row 3 minus 11 times row 2. 11 times row 2. 11 times row 2, let's see, 0, 11, negative 1, negative 2. 0, 11, negative 1, negative 2. Okay, so after subtraction, so 11 minus, okay, see here, subtraction, subtraction, subtraction. You will get a complete row of zeros. All right, and then we are going to write back the matrix, the system equation form. So the first one is x minus 2y is equal to 1. Second equation is y minus 1 over 11z is equal to negative 2 over 11. Right? And then from this one, from the last one, you get y is equal to 1 over 11 times z minus 2 over 11. And then you back substitute, you will get x is equal to 2y plus 1, which is, y is this, so 2 times 1 over 11 z minus 2 over 11 and plus 1, which is 2 over 11 z minus 4 over 11 and plus 1, it's plus 7 over 11. Okay, so what we get? We get the solution. X is 2 over 11z plus 7 over 11. And y is equal to 1 over 11 times z minus 2 over 11. What is z? Z can be any number. Z can be any real number. Okay, and this means the system equation has infinitely many solutions. It has infinitely many solutions. All right? And if we want to use the reduced echelon form, reduced row echelon form, here it's not reduced. Why it's not reduced? This position is not 0, right? If we want to use the reduced row echelon form, let's see how do we get those expressions or those answers. Let's continue here. We have 1, -2, 0, 1, 0, 1, -1/11, -2/11, and 0, 0, 0, 0. Okay, so this one is not the reduced one, reduced row echelon form, because here is not 0. Only this. Here, I even don't care because this is not number 1. Reduced row echelon form and the row echelon form, they only control the entries either below or above number 1s. They are not the first non-zero number, so they are not our control numbers. Okay, so how do I make this number 0? I will get a new row 1 as original row 1 plus twice of row 2. We multiply second row by 2 and add it to this place. So let me copy it. So 0, second row times 2. So this is 2. Oh, 0. This is 2. This is a -11/2. This is -4/11. -2/11, -4/11. And we're going to add this row to the first row. So 1 times 0 is 1. 2 times, -2 times 2, -2 plus 2 is 0. 0 plus -2/11, -2/11. 1 plus -4/11 is 7/11. So the rest of the entries, we just copy them. You see what is the situation? This column, 7/11, -2/11, they are the constant numbers. And the -2/11 and -1/11, they have a negative sign because they are still in the left-hand side of the equation. They're still in the left-hand side of the equation. If you move them to the right side of the equation, both negative sign will disappear. All right, so from here you can directly get x minus 2/11z is equal to 7/11. Y minus 1/11 of z is equal to -2/11. And then you move those two terms to the right side, you will still get the same solutions. Right? So you still have the same solution. So this is this one is a reduced row echelon form. The previous one is just a row echelon form. You can use either of them. All right. Next, let's try to use this Gauss-Jordan elimination to solve certain inconsistent system linear equations. So, example, we solve x plus y plus z is equal to 6. 2x minus y minus z is equal to 3. X plus 2y plus 2z is equal to 0. Okay, well, let's try to first write down the augmented matrix 1, 1, 1, 6. 2, -1, -1, 3. 1, 2, 2, and 0. This is augmented matrix. And I'm going to, okay, so here's already 1. I'm going to make this position 0, this position 0. So it's new R2 is original R2 minus twice of R1. So 2 minus 2. 2 minus 2, 0. -1 minus 2, -3. -1 minus 2, -3. 3 minus what? Here should be 12. 3 minus 12, -9. right? And new R3 is original R3 minus R1, 1 minus 1. So 1 minus 1, 0, 2 minus 1, 1, 2 minus 1, 1, 0 minus 6, negative 6. Okay? And then we interchange the row 3 and the row 2. Row 2 is a row 3 and row 3 is a row 2. Right? Just interchange them. And then here is a 1. Here is negative 3. I want to make this number 0. So we get row 3 is original row 3 plus 3 times the row 2. We multiply the second row by 3 and add it to the row 3. Okay, so negative 3 plus 3, 0. Negative 3 plus 3, 0. Negative 9 plus, remember it's some multiplication by 3. 6 by the negative 6 by 3 is a negative 18. Negative 9 plus negative 18 is negative 27. Now we have a problem about the last row. How do we know it's a problem? You check here, check here. This is consistent dependent case. The last row, all the entries from left and from right are always 0. If this happens, this is a dependent but consistent. The problem for this one is, the problem for this one is that on the left side, all the entries are 0, but here's negative 27. The last row means 0 times x, 0 times y, 0 times z is negative 27. But we know 0x, 0y, 0z, they are just 0. 0 equal to negative 27, which is impossible, right? So the system has no solution. And it is inconsistent. It is inconsistent. Okay, so if you have all zeros in the last entry, in the last row, all zeros in all entries 0 in the last row, then this is a dependent consistent. If all left entries are 0, but the right entry is non-zero, it's a inconsistent. It's inconsistent. Okay. Now let's see more examples. Let's see more examples. Okay, we have x minus 2y plus z is equal to 0. 2x plus 2y minus 3z is equal to negative 3. Y minus z is equal to negative 1. And the negative x plus 4y plus 2z is 13. We have 4 equations. No one says for 3 variables you can only have 3 equations. You can have more equations. Okay. So let's check, use the matrices. Let's check what is augmented matrix. It's 1, negative 2, 1, 0. 1, negative 2, 1, 0. 2, 2, negative 3, negative 3. 2, 2, negative 3, negative 3. 0, 1, negative 1, negative 1. 0, 1, negative 1, negative 1. Negative 1, 4, 2, 13. Negative 1, 4, 2, 13. This is a augmented matrix. Well, this position is already 1, so good. We just make this part a 0 and this part a 0. So the row 2 is old row 2 minus twice of row 1. Row 1 is there. Row 2, 2 minus 2, 0. 2 minus negative 4, 6. Negative 3 minus 2, negative 5. Negative 3 minus 0, negative 3. This is already 0. Let's copy it. Here's negative 1. We're going to add row 4 by row 1. Right? 1 plus negative 1 is 0. So 4 plus negative 2 is 2. 2 plus 1 is 3. 0 plus 13 is 13. Okay, and then I'm going to interchange row 2 and row 3. I want number 1 as the first non-zero entry in the second row. Other two rows not change. Okay, and then I'm going to make this position a 0 and this position 0. Okay, this is a row 3 is old row 3 minus 6 times a row 2. And the row 4 is old row 4 minus twice of row 2. Okay, row 1, row 2, not change. Here's 6 minus 6, 0. Negative 5 minus negative 6, you see? Times 6 is negative 6, subtraction. Negative 5 minus negative 6 is positive 1. Negative 3 minus negative 6 is a 3. And 2 minus 2 is 0. 3 minus negative 2. If you are not so sure, you can just write it down. You see, let's use a row 4 as an example. Row 4 is twice of row 2. Let's say twice of row 2. 0, 2, negative 2, and negative 2. This is row twice of row 2. Row 4, what is the row 4? Row 4 is here. 0, 2, 3, 13. Let's do subtraction. So you see, 0 minus 0 is 0. 2 minus 2 is 0. 3 minus, remember this is subtraction. 3 minus negative 2 is 5. Right? And 13 minus negative 2 is 15. Okay? So just be careful about the computation. If you're not so sure, just write them down and do the simple addition and subtraction. Okay, and the next, you see, the row 3, this is a non-zero number 1. The first non-zero number 1. Here is the second row, first non-zero number 1. The first row, first non-zero number 1. And before this number, this entry must be 0. So I'm going to make the row 4 0. How do I make the row 4 0? Row 4 minus 5, row 3. We multiply second row by 5 and use the row 4 to subtract the row 5. Row 4 subtract 5 times row 3. So the first 3 rows not changed, and this one 0 0. 5 minus 5 0. 15 minus 5 times 3. 5 times 3 is 15. 15 minus 15 is 0. So the last whole row is 0. Last whole row is 0. This is the row echelon form. We can stop here and use the system equations to find the answer. If you don't want the system equation, you can continue the row operation to make this row echelon form to be the reduced row echelon form. Okay, so let's see, how do I make the reduced row echelon? This one is called a row echelon form. Let's see, how do I make the reduced row echelon form? Here's a 1. I have to make this position 0. Remember, you have to do it step by step. For example, here, I have to make the last one, all the entries above 1, 0. After you finish that, you're going to move to the second and last one. Okay, so I'm going to add row 3 to row 2 and subtract row 3 from row 1. So row 1 minus row 3. Row 1. 1 minus 0 is 1. Negative 2 minus 0 is negative 2. 1 minus 1 is 0. 0 minus 3, negative 3. And row 2 is addition. 0 plus 0 is 0. 1 plus 0 is 1. Negative 1 plus 1 is 0. Negative 1 plus 3 is 2. Okay, the last row is this. Okay, so we first make these two positions 0. You have to make one column completely 0 and then move to the left column. This is order. You cannot change the order. If you change the order, you are wrong. And then I'm going to make this one 0. I'm going to multiply the second row by 2 and add it to the first row. So 1 plus 0 is 1. Negative 2 plus 2. Remember, we multiply the second row by 2. Negative 2 plus 2 is 0. 0 plus 0 is 0. Negative 3, okay, remember here is row 1 is original row 1 plus twice of row 2. So you have to multiply this 2 by 2 is 4. Negative 3 plus 4 is 1. Whenever you see all the entries 0 in one row, technically it means that row is 0 equal to 0, nothing. So you can drop it. You don't need to consider it. Then this is the reduced row echelon form. The reduced row echelon form. Then x1, y2, z3. The solution is 1, 2, 3. You can compare this answer with the answer from just the regular row echelon form. They are always the same thing. Okay, so for this part, all the computations are not difficult, but the whole steps, especially when you try to do addition, subtraction between rows, are tedious. Don't make your computation wrong. Do more exercise. Thank you.